Okay, so we all want powerful AI, right? Something that can sort through our data and just make our lives easier. But how do we get all that power without handing over our most sensitive, private information? Well, that's the big challenge we're tackling in this explainer.
So let's dive right in, because at the heart of this whole thing is a fundamental conflict. For anyone using AI today, it's kind of the classic case of wanting to have your cake and eat it too.
I mean, on one hand, you've got these incredible models like Google Gemini. Their power is amazing. They can summarize really complex documents, analyze data, even draft our emails. But on the other hand, feeding them our raw, sensitive data is a huge compliance and security nightmare. We're talking about accidentally exposing names, private emails, or even confidential medical records. That could lead to some serious violations of regulations like GDPR or HIPAA.
And this all leads to the one crucial question that everyone is trying to solve. How can we use the intelligence of these massive models on our private data without actually showing them our private data? Well, this is where Keystone Redactor comes in. It's this fascinating, open-source framework that's designed to solve this exact problem. And it does it with a really clever, security-first mindset. It's called the Keystone Redactor framework. And honestly, the best way to think about it is like an automated security guard for your data. It creates this pipeline that, finds the sensitive info, hides it, lets the AI work its magic, and then puts it all back together, all while keeping your original data completely private from any third party.
So how does this magic trick actually work? It all happens in this secure, four-step workflow. Let's break it down.
It follows a really simple but incredibly effective sequence. First, it detects sensitive info using natural language processing. Then, it redacts it, sends that safe version off to be processed by an AI, and finally, it restores the original. Let's see it in action.
So it all starts with the input text, right? Here we have a request that contains a few different types of personally identifiable information, or PII. We've got a name, Dr. Evelyn Reed, a date, an email address, and a money value, all things we absolutely do not want to just send out to some external service. Next up is the redact stage, and this is where it gets really clever. It acts like a digital safe. The framework finds each piece of PII and just swaps it out for a generic placeholder. So, as you can see, Dr. Evelyn Reed becomes person A, the date becomes date A, and so on. The whole time, the original data is stored safely on the side in a totally private map. And this right here is the key. This redacted, anonymized text is the only thing that ever gets sent to the AI. The model totally understands the context. It knows a call needs to be scheduled, but it has zero access to the actual private details. And finally, after the AI processes the request and sends a response back, the framework swoops in and restores the original data. It just swaps the placeholders back out, using its private map to kind of unlock the information. The result is a really useful AI response for the user with privacy completely maintained from start to finish. Okay, so where would you actually use something like this? Let's take a look at some real-world applications where this level of data security isn't just nice to have, it's absolutely critical.
Yeah, this isn't just some theoretical tool. It's designed from the ground up for some serious challenges. We're talking fields like healthcare, where you have HIPAA compliance to worry about, the energy sector, for protecting critical infrastructure details, and of course law, for maintaining attorney-client privilege.
For instance, take a hospital setting. This framework could summarize a patient's consultation notes for an insurance claim. It processes all the details of the visit while making sure that protected health information, like the patient's name and date of birth, remains completely confidential and never, ever leaves the hospital's secure system. So, why does all of this matter so much? Well, because this kind of privacy-first approach is absolutely fundamental to building AI systems that we can actually trust.
When you boil it all down, the benefits are crystal clear. You get zero PII exposure to third-party services. You can build workflows that are automatically compliant with big regulations like GDPR and CCPA. And for any business, you get a full audit trail inside a production-ready architecture. It's the whole package.
This leaves us with a pretty big final thought. As we integrate AI deeper and deeper into our daily lives, frameworks like this one feel like a really critical step forward. They're helping unlock AI's full potential by proving that we can innovate both powerfully and responsibly. So, is this the key to building an AI we can finally trust?